Okay, today's lesson is section 5.2, and we're going to be graphing quadratic functions, and there's really two types. We're going to start with the easy type first, and what makes this type of quadratic function easier, and I've made a note for you over here off to the side, notice there is no linear term. There is no x term in this function. We have the quadratic term, and we have the constant. So what this means when we have no linear term, first of all, locating the AOS is pretty simple. Because when there's no linear term, the AOS is always the same. It's the vertical line x equals 0, which is another way of saying the y-axis. So we have symmetry. We're going to have a parabola that will be symmetrical around the y-axis. And so when we do the AOS really isn't a part of the graph. It's just a tool to help us construct the graph. So we'll do the AOS as a dotted line, just to show that it's really different from the actual graph of the parabola. Okay, no linear term. We know where the AOS is. We don't even have to calculate it. It's pretty simple. Another thing that's very easy to determine when there's no linear term is the vertex. Because the vertex, remember from yesterday's lesson, is always on the AOS, and it's in particular going to be wherever the constant is on the y-axis. So the vertex in this case is going to be the point 0, -4. So if you want a general way of knowing where the vertex is when there's no linear term, it's going to be the point 0 and then whatever the constant happens to be. Okay? Another thing you should always notice is take a look at the a term. In this case, a is 2. That's positive. So what that tells me about this parabola is that it's going to open upward from the vertex, which means the vertex represents the very bottom point of the parabola. Or in other words, we would say that we have a minimum value at, in this case, -4, because that's the y-coordinate of the vertex. If the parabola opened upside down, then, just a rough sketch, has nothing to do with this parabola, but if the parabola opened upside down, then the vertex would be at the very top, and we would have a maximum at whatever the y-coordinate of the vertex happened to be. Okay? And in some of your problems for the homework, they're actually going to have you construct a graph and then identify whatever the maximum or the minimum value is. And so just read your instructions so you'll know which ones to do that extra step for. All right, so we're pretty much ready to start graphing, and now it's just a matter of picking a couple of numbers to plug in for x. So we're going to do inputs for outputs. And just think of the AOS as the center, and I just always like to think about building this parabola from the middle. All right, so here's my middle part where the AOS is. And I'm just going to start plugging in some numbers for x that are really close to the AOS. Like, for example, x is 1. If I let x be 1 in this function, what comes out for y? What's the output? Anybody know? Adam? 4? Well, let's see. 2 times 1 squared minus 4.
No.
-2? Okay, that sounds good. So we'll just plot the point 1, -2. 1, -2. And the great thing about symmetry is if I have one point that I've calculated, it's like you get a bonus point without having to calculate, because on the other side of the AOS, there's a matching corresponding point. This is why we did the P prime, Q prime exercise yesterday. Okay, so you would understand how to match up corresponding points. All right, so let's just pick one more number, like x is 2. What is the output value for an input of 2? 4. All right, very good. So here's 2, 4. And once again, I don't need to calculate the other point because symmetry tells me that it has to be over here. And for all your parabolas, you're going to use 5 points. The vertex, and then 2 calculated points to go along with the other 2 because of symmetry points. That should be easy to find. And now it's just a matter of connecting the dots. Tough for me to do, but remember, this is not a V. This is a U shape. So do your best to, and it's kind of tough sometimes when the points are really close together, but do your best to do a smooth curve V shape. I'm not grading you on your artistic ability, but just don't make them V's, okay? Do your best to make them U shapes. Any questions on that? Okay, we're only going to do one more of these, and then we're going to go to the ones that do have a linear term because they're going to take a little bit more time. They're not quite as easy. So for this one, raise your hand if you can tell me what the AOS is. What is the AOS? That's where we begin. All right. Thomas. Okay, we would say it's x equals 0. Very good. Or in other words, you could say it's the y-axis. So again, no linear term makes it easy to find the AOS. We're going to find out in just a little bit that when we do have a linear term, it's not quite so easy to identify the AOS. It's not hard, but it's not as easy as this. All right, so give me a volunteer to help me out with the vertex. Where is the vertex on the y-axis? Yeah?
0, -5.
Awesome. Mr. Avery comes through. 0, -5. So, somebody else tell me how this parabola is going to open. Up like a cup or down like a frown? Which one? Yes. It opens up. How come? Dalton? Which is positive? Okay, the A number in this case, it's a little bit out of order, but A is the number in front of x squared. It's positive, so that tells me that I have a minimum value. And what is that minimum value in this case? Adam?
-5.
Awesome. I have a minimum value at -5. Very good. Okay, now it's time to choose some inputs and calculate some outputs. So let's just go ahead and say, what is the output for an input of 1? Raise your hand if you could give me that. Input 1, output what, Zan? -2. Very good. So here's 1, -2. And I get a bonus point because of symmetry. All right, now let's try an input of 2. Logan?
+7.
+7. Sounds good. So here's 2, 7. And because of symmetry, I have another point over here that matches it, corresponding point. And then you do your best to make a U shape out of those 5 points. And we're done. Okay, yeah?
Are we ever going to do it on the x-axis? I think you mentioned it yesterday.
Well, that's a great question. The inverse of these, the inverse of this upright U shape is a U on its side. So, and that's going to be chapter 6. We'll get into that. You won't have to worry about that tonight or any time throughout chapter 5. Good question, though. Yeah? The y coordinate? We're plugging these numbers in for x up here in this function. So let me show you how it works with x equals 2. So y equals -5 plus 3 times 2 squared. You always do the exponent first. Yeah, make sure you do the order of operations. All right, anybody else? We're not going to do this next one. I just want to kind of set it up. Raise your hand if you can tell me where the AOS is. Logan?
0.
Okay, x equals 0. Very good. The y-axis. How does this open up?
Down.
Okay, that's kind of a weird way of saying that. How does it open? It opens down. Very
Frowny
good.
face.
Frowny face. All right. What's the vertex, McKinley? 0, -1. Very good. We just look at the constant. That's what's so great about these no linear terms is all we have to do is look at the constant, and that is the vertex on the y-axis. Everything's symmetrical about the y-axis. Okay, I think you've seen enough of those. Now let's include the linear term. This is going to involve a 4-step process, which you probably saw in Algebra 1, but you may have forgotten, so we're going to review it. So be on the lookout for the linear term. When you see the linear term, then you can't just say, I've got symmetry on the y-axis. You're going to have to calculate where your line of symmetry is. And I'm going to give you a little formula. So we're starting to accumulate some formulas, and if you don't practice these, you're going to have a tendency to let some formulas mix in with other formulas that you've already learned. So your practice of these is very, very important. All right, so drill this process so it makes it easier on the test. Okay, what this says is to find the AOS, I'm going to do this little calculation which says the opposite of B over 2 times A. And I went ahead and labeled, you know this from last night's homework already, but I've labeled the A, B, and the C numbers from standard form. Okay, so finding the AOS means this. The opposite of B, which is -12, divided by 2 times A, which is 3. Okay, I use parentheses like this because I'm going to figure out what B over 2A is first. For me, that just helps prevent making a mistake with the sign. So just looking at the B over 2A part, what is -12 divided by 6? That is -2. But the formula says to do the opposite of -2, which is +2. So my AOS is going to be the line x equals 2. Now I'm going to erase this, so hopefully you have this in your notes already. So if you don't, go ahead and get that down so I can draw my x equals 2 line. Yeah?
So that's how you find the AOS?
That is how you find the AOS every time. The opposite of B over 2A. If there's a common mistake that's made, it's right here. A lot of people end up putting their AOS on the opposite side of where it should be because you've got to remember this opposite of. Okay? Can I erase this? Everybody good? All right. So if you haven't already, sketch the line x equals 2. Here's the AOS. Well, remember the vertex is on the AOS, or yesterday we presented it like the AOS always goes through the vertex. So our vertex has to be on this blue dotted line somewhere. And here's how I find it. Step 2. Whatever I got for my AOS, whatever that number is, I'm going to plug it back into the function for x. Because my vertex has to be the ordered pair to something. Y has to be some number. Well, I will know what y is when x is 2 when I plug 2 in for x in the function. Okay? So let's see what that becomes. Y equals 3 times 2 squared minus 12 times 2 plus 10. Remember the order of operations. This is 4 times 3, which is 12, minus 24 plus 10. Put all those together, and what do you have? 12 minus 24.
Oh.
-12 plus 10 is -2. So the vertex is the point 2, -2. Okay, everybody see that? Yeah.
So you plug in what x was.
Yeah, whatever you got for the AOS, you just take it back to your function and plug it in for x, whatever that number is. Yes?
And so if you don't have a linear term like on the other problems, then the vertex, the x, and the vertex is 0.
If there's no linear term, then the vertex is just whatever that constant is on the y-axis. Yeah, that's why these are kind of a lot easier. And you didn't stay there. Okay. Everybody good? All right. So let's just go ahead and observe, based on our A number, how is this going to open? It opens up. So we have a minimum at what number? -2. You won't have to do that for all the problems, but I'm just including it. You read the instructions. If it asks you to identify the maximum or the minimum value, this is what you're going to do. The y-coordinate of the vertex. If the parabola is upside down, it's a maximum. If it's right side up, it's a minimum. Okay, here's an easy point to plot. I like number 3 because it's very easy. There's nothing to calculate. It says to plot the y-intercept. Well, the y-intercept is the constant on the y-axis. So you could say it like this. It's the point 0, C. In this case, that means 0, 10. Now, you only have 9 lines, right? So it's okay, since you just need one more, just go ahead and make another one at the top of your y-axis. And let's plot that point. 2, 4, 6, 8, 10. And symmetry, that's what this means, and its matching point. So we'll go across the AOS, and we'll put another one. So we got 3 of our 5 points plotted. Anybody confused? Okay, we're ready to do step number 4, which is going to involve plugging a number in for x. We get to pick a number. Technically, it can be any number you want because x is an independent variable, but I just have this thing about building from the middle. And I notice that as I build from the middle, I have a gap. I do not have a point right here where x is 3. I also don't have a point on the parabola right here where x is 1. Everybody see that? I do know what y is when x is 0, and I know what y is when x is 4, but there's like a missing piece to this parabola real close to the AOS. So for me, I'm going to let x be 1 in this function. 1 is the input. What would be the output? Hannah? 1. Very good. So the point 1, go back to the origin, 1, 1 is on this graph, which means this is the matching point for it. And now you're ready to, you got your 5 points, you're ready to connect the dots. Yeah?
When you have your minimum point and you're doing inputs and outputs, so say if you were doing the right one first, would it be 3 or 1?
You're talking about,
Putting it in for x.
you would put in 3. I mean, you get the same thing if, you know, if we had put in 3 for x, we would have also gotten 1 as the output.
So you like count over how many
From
from the
the AOS. No, you actually, like here's the AOS. This is where x equals 3. So you would put in 3 for x. This is where x equals 1, so you would put in 1 for x. Did I answer your question? Okay. Everybody good? Think you got it? I'm going to do some examples on a separate video, actually some of the problems that you're going to have to do. I don't think we're going to have time to get to this one, but how does it open? Opens down. You have your 4 steps on how to find the AOS, the vertex, the y-intercept, and then plug in another number. That's what your 4 steps are. Any questions? Yeah.
So really what we need to, I just remember would be to plug everything in with linear problems.
When there is a linear term, you're not always plugging everything in. In some cases, you're calculating. Like this is going to give you the AOS. Now you will be plugging that in to find out what the vertex is. Whatever you got for the AOS, you plug it in. Okay. You don't have to calculate anything for this third step. It's just whatever the constant is on the y-axis is a point. And then you will be plugging in a number for x here. Okay. Here's your assignment. Let me skip over. And just read your instructions. I think the first 4 are no linear term. The next, I can't remember how many, but the next block of problems will have a linear term. And then I think the final block of problems, you're graphing and telling whether you have a maximum or a minimum. Okay. Shout out to 7th period. Great job.